These are our LEDs. This is the HC-05 module and this is a mobile phone, and I have shown you how to install the app. Now let's connect it. See, the state LED is right now off, but as soon as it will be connected, it will turn on. See, now it's on because it shows that it's connected. Now I send A. So I had written, let me write A. This is A. I send it. See, the A LED turns on. Now I write B. This is B. I send it. Now the B LED is on. Now I write C. This is C and I send it. Now the C LED is on. See, this is as simple as that. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can interface a HC-05 Bluetooth module with a PIC16F877A microcontroller using default settings. So let's get started. So guys, default settings are basically those settings. When you buy the module, they come at default setting. You buy a new module, it is in the default settings. So in this first video on HC-05, I'm going to use the default setting. So these are the default settings. Your baud rate is 9600. Your password is 1234. Your default mode is the data mode. You have two modes, command mode and the data mode. In the command mode, you can change this baud rate of the module and also the password, etc. While in the data mode, you only operate the module. Like you have done the settings in the command mode, you had changed the password and the baud rate. Now to operate it in the normal mode, that is called the data mode. So by default, it's in the data mode and password is 1234 and baud rate is 9600. And by default, auto pairing is also on. It means that it will auto pair to last known device and it's on. So let's use these settings to do some useful work. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP variant. And this is HC-05 module. As you can see, I have this type of module. It's also available with less pins as well. So as you can see that we have a button here. It is to switch between command and data mode. You don't touch it. If you have a new module, just leave it as it is. We have total of 1, 2, 3, 4, 5 and 6 pins. Here, if you hold it like this, then let me label them up. The bottom pin that's next to the button is the enable pin. Then we have VCC pin, then ground pin, then TX, then RX, and then the state pin. So guys, as you can see here, we have the TX and RX pin. It means that it's a UART based module. So you will need the UART pin of the pins of the PIC to interface this. So guys, let's do the connections. So first of all, let me explain to you this enable pin. Whenever you are using the module in the data mode, it needs to be just leave it floating. Don't do anything to it. Leave it open. Just don't connect it to anything. It means your module is working in the data mode. That is the normal operating mode. But if you want to change the 80 commands, like you want to change the password and the baud rate, then you have to send 80 commands. Then you have to connect it to the high. You can say that high pin. You have to send it high. You have to send a 1 to it through a microcontroller. Either you short it with a VCC or use a jumper. That's all. Now guys, this state pin, basically you connect an LED to it. It shows that is your module connected to a device or not. It's on, but still there is a problem that either the module is connected to a device or not. If it is successfully connected, then this pin goes high. It means the LED connected to this pin will turn on, else it will remain off. Now let's connect it to the PIC. So guys, VCC pin will go directly to the VCC pin of the PIC. It works on the 5 volt, ground to the ground of the PIC. And TX will go to the pin number 26 of your PIC. That is the RX pin of the PIC, like this. Then guys, RX pin will go to the pin number 25 of the PIC. And pin number 25 is the TX pin of the PIC. In this way, your UART connections are completed. Now for the state pin, I will use an LED like this. An LED has two pins, one longer, one shorter. So for the longer pin, I will use a 220 ohm resistor. It's a safety device to save the LED from getting burned. Now you connect the state pin to the one end of the 220 ohm resistor. Then from the other end of the 220 ohm resistor, connect it to the longer pin of the LED like this. Now the other pin of the LED is the ground pin. Just connect it to the common ground of the circuit like this. Now guys, what we are going to do here is that we will use three LEDs, these three LEDs, and we will send commands from our mobile phone. When I will send A, it means the rightmost LED will turn on. When I will send B, the centermost LED will turn on for 3 seconds. and when I will send C, the leftmost LED will turn on for 3 seconds. That's all what we are gonna do in this first tutorial. So for that purpose, we need to connect these LEDs as well. So let's connect them. As you know, each LED has 2 pins, one longer, one shorter. Shorter is the ground, common them and send them to the common ground. And for the longer pin, you will need a 220 ohm resistor for each LED like this. Now for the rightmost LED, okay, let's start with the top LED. You connect the longer pin to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, you can use any available digital input output pin of your PIC. I'm going to use a pin number C4 for this like this. Now guys, for the rightmost LED, connect the longer pin to the one end of the 220 ohm resistor like this. Then from the other end of the 220 ohm resistor, again you can use any available digital input output pin. I'm going to use the pin number D3 like this. Now guys, for the leftmost LED, for the longer pin connected to the one end of the 220 ohm resistor like this. Now from the other end of this 220 ohm resistor connected to any available digital input output pin of the PIC, I am going to use a pin number D2 like this. In this way, our LEDs are connected and our HC-05 Bluetooth module is connected to the PIC. Now guys, what we are going to do is that I will send A from the mobile phone to the circuit, and one LED to the right will turn on. When I will send B, center LED will turn on. When I will send C, the leftmost LED will turn on. Before we move on to the programming, let me introduce you to the hardware. So guys, this is the mobile phone I am going to use in this video. I will show you how to install the app and use it. Then guys, these are the 3 LEDs here, 1, 2 and 3. We are going to use here rightmost, center and leftmost. And then this is the state LED. This is connected to the state wire of your HC-05 module. So this will only turn on if our module is correctly connected. Like we are doing connection from the mobile phone. If the connection between mobile phone and the module is successfully established, then the state LED will go high. It will turn on, else it will remain off. And this is our PIC16F877A in the back. The rest is just a trainer board. I will also give you the link of the video in which I will show you how you can set up this hardware for programming. So guys, let's move to the MikroC for PIC and let's get started with the programming. So guys, this is here is our MikroC for PIC. Let me zoom in for you. So guys, as you can see that this is MikroC for PIC version 7.2.0 I am using here. You can use the higher versions as well if available. Higher is always the good. So first of all, click on File, New Project. Now guys, this window pops up, New Project Wizard. Click on Next. Write the name of the project. I write HC-05 Tutorial by Learning Microcontrollers like this. Now guys, the next thing is the path where you want to store the files. The next thing is the microcontroller you are going to use. I am going to use a PIC16F877A, and the next thing is the clock you are going to use. This clock is the crystal you had connected to pin number 13 and 14 of the PIC. I have a 20 MHz crystal, so I am going to write 20 here. Whatever the crystal you have there, just write it here. Click on Next and finish. Now guys, this window pops up. First of all, save your work. Before you do anything else, press Ctrl S. The work is saved. Now guys, the next thing is go to the right, expand this MikroC system libraries, and here you write the UART. Check mark this library because we are going to use the UART port because it's a UART module. Now guys, go to the left, write down the first command, initialize the UART module, write down UART1 underscore INIT, and the baud rate is 9600. Why 9600? Because by default HC-05 baud rate is 9600. So that's all. That's why we have 9600 baud rate. Give some initialization delay here. It's not necessary, but I suggest you always give it in the one-time loop. So I give just 20 millisecond of initialization delay. Now we have 3 LEDs as well. Let's initialize them one by one. First of all, trace C.F4 equals to 0. That's one LED that we have. And give the initial state. Port C.F4 equals to 0. This command over here is like pin mode command in the Arduino. Pin mode input or output. If it's an output, then you write 0, and if it's an input, just write 1. And here you select the pin, and this is a register. And this command is like a digital write low or high in case of Arduino. So So in case of MikroC, you write it like this: port, then you write the pin, and then 0 means it's a low and 1 means it's high. So that's all. Now give some initialization delay for this pin. Now let's do it for the other two LEDs. Just copy this, paste it 2 times. So like this, make it look presentable like this. Now guys, the second LED is at pin D.F3. Just make it D.F3, change the pin D.F3 like this. Also do it for the third one, D.F3, D.F3 like this. Now guys, go to the forever loop. We have our 3 LEDs initialized, we have our HC-05 initialized. Now we can move on to our forever loop. Write down while 1 starting here, ending here. Now inside it you will write, first of all we will need to read the value coming from the HC-05. For that purpose, go to the void main. Above the void main, take a char variable, char read 1, that's all. A char can store only 1 digit like A, B, C, D, whatever we have. Now you go to the right in the UART library. Here you have this UART read command. Double click on it. This command over here in the example here, you copy it till here like this. Now go back, paste it here. Now this will check if your receive buffer is empty. If it's empty and data is also available, then it will read the data, a char only, and it will store it in this read 1 variable that we have just made here. Now guys, we have our data from the HC-05. Now I write if read 1 this is double equal to A. That's what we got from HC-05. Then what it should do? Then it should turn on one LED, that is pin number C.F4, the LED at C.F4 like this. So this LED will turn on. Now else if, again check, else if read 1 is equal to B, then the other LED will turn on. This LED turns on like this. Now for the third LED, else if it's equal to C, the value we got from the HC-05 is C, then the LED at D.F2 will turn on. Else if none is received, then all the LEDs must turn off. So make it 1, they have to turn on here. And then if nothing is received, like HC-05 is sending nothing and it's just ideal, then what should happen? No LED should turn on. D.C.F4, D.F3 and D.F2, all 3 LEDs should remain off. Make them 0. So they are off. And also remember that also your read 1, that is this command, this variable should have a different value that is not being used in the code. Like Z is not used here, just give it this. So else it should be Z. If it accidentally becomes ABC, then what will happen is that your code will cease to work. So also you do this in the one-time loop. So whenever the code starts, by default its value should be anything else other than 1 being used here. So this is how you trick it. Now the LEDs will turn on for how long? I make it like for 3 seconds. So LEDs, okay, let's make it 2 seconds is fine. So whenever A is received, LED at C.F4 will turn on for 2 seconds, and if B is received, LED at D.F3 will turn on for 2 seconds, and if C is received, LED at D.F2 will turn for 2 seconds. Let's build the code, check for errors, no error, build it again, check for errors again, no errors. So go to the PIC16F877A programmer tool, click on file, import hex file. This is the file I just created, click on write. Okay, the new file is being written. Let me zoom out and let's get to the hardware. So this is our hardware over here. You can see the new file being written. Okay, the new file is written. And see that no data is coming. HC-05 is on and you can see the state LED. This is our state LED and it is off. See, it's off because it's not connected right now. Now what I do is that I show you how you can install the app. I turn it on, go to the Play Store. This is the Play Store over here, and in the Play Store you write down, okay, let me do it again for you. Here you will write HC and then you should add a dash here, 0 5 HC-05 Bluetooth terminal. Okay, here we got, you will write this HC-05 Bluetooth terminal. Now there are various terminals, as you can see here. You can select any. I suggest you check this one because it's on the top, or you can also get the APK files from the Google as well. That's all, that works fine. Now install this serial Bluetooth terminal. There are various other as well, so I'm going to use this. It's light, just small enough. Okay, it's installed. I enable it. Now open it. Okay, it will lead you to this window here. See that nothing is happening. Okay, I touch this button over here. Okay, it asks for the Bluetooth to be connected. Allow it the Bluetooth access. Remember that Bluetooth should be on. So Bluetooth is on. You can see that it's on. So what I do is that now just you have to select the device you want to connect. Click on this connect button here. This is the connect button. Okay, no device selected. Okay, select our device. Go to the setting. Okay, go to these three bars. Here you have these devices. Click on devices. This is our device that's on HC-05. This is this device. By default, its name is HC-05. You also add this. So I select it. Okay, it's saying connected to HC-05. See, now this LED has turned on. See that it shows that the device is connected. So I disconnect the device. See, it has turned off. So if the device is connected, I connect it again. See, it turns on. If the device is successfully connected, only then this state LED will go high. Now I disconnect it. See, it's gone. I connect it again. See, now it turned on. Now what we do is that we have other LEDs as well. We have to send a character like A, B or C. So click here. And we have given a small, remember we have given small there. So I will send A now. See what happens. Okay, the LED turned on for 2 seconds and then turned off. I send it again. A, see, it is working fine. Now I send a B, the other LED will turn on. Okay, here you have B here. Okay, this is B. Now I send it. See, the other LED, center LED turned on. I again send B. Again it turned on for 2 seconds. See, our code is working. In this way you can interface a HC-05 module with a PIC microcontroller by default settings. Again, see the B. Now I send a C. The third LED will turn on. So this is C. I had selected the C. Now I send it. So see, I have found the problem, guys. So that's in the programming. So let me zoom in. See that we did wrote the code well, but there is a problem here. See, when we were initializing the pins, we changed to, I just copied pasted here. So it is D.F2. So D.F2 is the C. I also write it here. This is A. This is B. So sometimes it happens you have to debug the code at various stages. This is C. So it was D.F2. I forgot to change the pin. So let's rebuild the code and write it. Okay, the new code is being written. Let's get back to the hardware. So it writes up. See, the state pin is still on because it is connected. It has not been disconnected during programming. So it sends random values when you have connected it during coding. Now we see, this is the benefit of the state LED. Still we know that it's connected. Now I send a C. I had just programmed the C. So this is C. I send. See, the C LED is on now. Now again I send C. See, it turns on for 2 seconds. Now I send B. See, it's working. Now I send A. This is A. See, it's working. A, then B, then C. So guys, this is as simple as that. It's very easy to use. In the future videos, we will also make some complex projects using this HC-05 module. So guys, now let's disconnect it and see the LED turns off or not. See, it turned off as soon as I disconnected it. So guys, this is it. Thank you very much for your time and patience. I will give you all the MikroC for PIC files and hex file as well, which includes all the files that come with the build. I will send them to my Google Drive, and I will share the link of that Google Drive file folder into the link of this video in the description of this video. So guys, if you have any questions, you can ask in the comments. So have a nice day, and we'll see you in the next video.